All right, we'll tackle number 37 here. Of the 455 students at Jorge's school, 420 are native English speakers. And then it goes on to say, let me zoom out a little, what fraction are native English speakers? All right, so they're going to want us to write the fraction, and they are going to want this in simplest form. So 420 out of a total of 455 are native English speakers. Okay, we can simplify this. There's different ways to show it. A lot of textbooks will use prime factorization and then cancel common factors. Again, I just like to think of a number that will divide evenly into the numerator and denominator, and then just simply proceed that way. All right. So obviously 5 will divide into each of these. So just in case it doesn't click real fast in your head, you just say 420 divided by 5 goes in 8 times. 5 goes into 20 4 times. So 420 divided by 5 is 84. Okay. And then 555 I have to divide by 5 as well. 455, I'm sorry, I might have said 555. 455 divided by 5. That goes in there 9 times. 5 goes into 5 once. So 455 divided by 5 is 91. And using our tricks, 2 won't go in, 3 won't go in, 5 won't go in. Then after that, the next candidate would be a 7. Oh, they are sneaky. 7 will go in there because 10 times 7 would be 70. And then 3 more 7s would give you your 21. And wow, 7 will go into 84 as well. Well, they're being a little bit sneaky here. Alright, so 84 divided by 7. In case you don't see it, 84 divided by 7 is 12. Alright, and 91 divided by 7, I have to use the same number here. Say 91 divided by 7, it goes in once, and 7 goes into 21 3 times, so this becomes 13. Alright, so 12/13 of the students are native English speakers, and that's a little bit easier to get a handle on. 12 out of every 13 students are native English speakers. Again, paying attention to the ones column is a way to contemplate possible divisibility. The more you work with these numbers, the better you will get. And let's see, that's 37. Alright, for number 39, they want us to determine which numbers in the list below are divisible by both 3 and 5. And they're just trying to reinforce the tricks we've learned for seeing if numbers are divisible by 3 and 5. If you notice, this one up here is 2 and 5. So they're just trying to keep your skills ready to use. They will come in handy. Alright, so let's see, both 3 and 5. Well, it's real easy to check whether or not 5 will go into a number. So let's see if, from our long list, if we can eliminate any. 5 will go in there, but 5 won't go in because it ends in a 3. So we can cross that off right away. All right, we're focusing on our 5 right now. 5 will go into that, it will go into that, it will go into that. 5 will not go into 212, so we can cross that. Okay, so now we just have to look at these 4 numbers and see which of them are divisible by 3. Alright, so now we're going to focus on the 3. And you have to remember the trick. If you add up all the digits and that sum is divisible by 3, then the original number is divisible by 3. 5 plus 9 plus 0 is 14. Is 14 divisible by 3? No. Well, then that's not divisible by 3. 7 plus 8 is 15. Is 15 divisible by 3? Yes. All right. Got to add up all these. 8, 10, 15. 15 divisible by 3? Yes. And finally, we'll add up all these. There's 15, 16, 21, 30. Is 30 divisible by 3? Yes. So 7,080. I should use a different color because this is in the winner circle here. 7,080, 5,325, and 96,195 are these three numbers are divisible by 3 and 5. All right. So the 3 circled in blue, that would be your answer. Take a look at number 43 here. And perhaps, well, we'll just keep things right where they are. Now we'll zoom in just a little. Get this out of here. All right, so for 43, we are to multiply these fractions, and it's always a good idea to reduce when you can. We can make our life a lot easier here. So I happen to remember from earlier on that 8 goes into 120. So well, I wonder if that doesn't occur to you, I could reduce very quickly this way, but maybe I'll just reduce top to bottom here. So 5 goes into 45 9 times. 5 goes into 120 24 times. All right. Cross out these numbers once you've divided them. Okay, so 45 120ths just turned into 9/24. It's the same value, it just looks a lot different. All right, and I could reduce the 8 and the 10, but I'll just reach across. What the heck? I know 8 goes into 24. So 8 goes into 8 once. 8 goes into 24 3 times. Chop that down pretty fast. And then 3 goes into 9 3 times. 3 goes into 3 1 time. And what is left standing? You multiply straight across. 1 times 3 is 3. 10 times 1 is 10. So 8 tenths times 45 120ths is 3 tenths. All right. I strongly encourage you to get comfortable with canceling, and there's certainly many other ways you could have gone about doing that. Okay. Number 44. This might look confusing. Whenever you're pretty much, addition, subtraction, maybe you wouldn't go here, but if you're multiplying or dividing and you have a fraction involved, you want all fractions. So I'm going to turn 40x squared into a fraction. Now it's a fraction. You can always put a number over 1. You can always put a variable over 1 because you're not changing its value. Anything divided by 1 is whatever you started with. So I didn't change its value, I'm just changing the way it looks. Okay? And let's see, 8 goes into 8 once. 8 goes into 40 5 times. That's all the reducing we're going to get away with here. So we multiply straight across. We have 5 times 3 is 15. And x squared, nothing's going to cancel anything out. So x squared just comes along for the ride. This is 1 times 1, so it's 15x squared over 1, but there's not much point in writing that. Okay, so that takes care of 44. And let's see what's up next here. We'll take a look at 46. A little more canceling. I think I'll do this two ways. I'll write out, this is the same as x. Here's that x. Z to the third is z times z times z. So all I did was rewrite z to the third. I don't know if that blue is showing up. And this is all over a y. All right, times y on top, and x times z on the bottom. And now we'll cancel our common terms. So x goes into x once, y goes into y once, and of these z's, this z will cancel one of them. You'll be left with two z's. All right, so this is equal to z squared over 1, but there's not much point in writing that. Sorry, I got off my page a little. Time to zoom out. There we go. But usually, instead of writing it out, I'm just going to clean it up right here. Okay, y goes into y once. X goes into x once. And I'm getting rid of one z on the bottom. So instead of having 3 up top, I only have 2. So that's z squared. So I'll go in this direction. I have z squared over a 1, but I don't really need to write that. Alright? So either way, you'll end up with a z squared. I just thought I'd show a little more detailed approach. If you get confused reading these exponents, write out what they mean. And I think that would be helpful. Alright, we'll take a look at another exponent showing up here, but in a slightly different case. And let's zoom in some. This might be a bit small for you. There we go. Now, reading the shorthand of mathematics, when the exponent is present, whatever it's touching, that's what it applies to. So number 47 here, the 2 is touching the parentheses. That's what you have 2 sets of. All right. We happen to know that there's a negative 1/6 inside each set of parentheses, and parentheses next to parentheses means to multiply. So when you do that, you multiply straight across, you get a positive 1/36. Okay, negative times negative is positive. Number 48's order of operations. So first you'll have to calculate, well, maybe I'll say that a little differently. I mean, the order of operations is always in play. You just don't always have to pay a lot of attention because something else has got your attention. But here, we're going to follow the order of operations strictly, and exponents precede multiplication. So we'll deal with that. Parentheses precede exponents, but there's nothing within parentheses that we can do. Okay? So again, the 2 is touching the parentheses. This 2 is touching parentheses. So I go off to the side and do my calculation. I've got my 2 sets of parentheses here. We've got negative 5/7 in each one. And when you multiply that, you get negative times negative is a positive, 25/49. So right underneath here, I simply put 25/49. 49ths. And then I bring down whatever I haven't used. I haven't used times 1/5. And I really don't feel like multiplying 5 times 49. And fortunately, I can reduce. 5 goes into 5 once. 5 goes into 25 5 times. When you multiply, you go straight across. 5 times 1 is 5. And 49 times 1, 49. So that's the result of that one. Let's see. When you divide by a fraction, you take the reciprocal and multiply. Another way of saying you flip it and multiply. You cannot reduce until you're ready to multiply. So like down here on number 51, you cannot say 10 goes into 10 once and 10 goes into 10 once, because this is still in division. Maybe I'll zoom in a little bit on that. These are all division signs here. Division, 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 division. It's a negative sign next to a division sign. Alright, so let's see. We'll tackle number 51. And this is 7/10 times a negative 12y over 10. We can do a little bit of reducing here. 2 goes into 10 5 times. 2 goes into 12 6 times. And we've reduced all we can. Negative, well, 7 times negative 6 is negative 42. This y is just coming along for the ride. And 5 times 10 is 50. So that's our answer to that one. And let's see. We'll tackle number 53. Okay. So on number 53, again, this is division. When you divide by a fraction, you have to flip it and multiply. So we've got 15x squared over 40y times, I'm going to flip this, 64y over 25x, and I will certainly cancel anything I possibly can. So let's see. 5 goes into 25 5 times. 5 goes into 15 3 times. I'm going to go ahead and take care of the x's. X goes into x once. I have 2 x's up here, so now I canceled out one of them. And let's see. 8 goes into 40, 8 goes into 64. Okay, so 8 goes into 40 5 times. 8 goes into 64 8 times. And y goes into y once. So those become 1s. Since we're multiplying, you don't really have to pay attention to them anymore. Okay, so 3 times 8 is 24, and this x is still hanging around up here. And then you have 5 times 5. All right, so that's our solution to number 53.